Alright, welcome to the P2 video for polynomial expressions. Our goal here is to add, subtract, and multiply polynomial expressions. This video is really going to concentrate on adding and subtracting polynomial expressions. When it comes to this, I'm going to make this as simple as I possibly can. So, when it comes to addition, we're going to drop parentheses, and you'll understand what I mean here in a second, and combine like terms. When it comes to subtraction, we're going to distribute the negative 1, alright, so that's negative 1 in there, and then combine like terms. I don't know why I do this. C-O-M-B-I-N-E, right? I cannot spell for the life of me. Alright, so that is as basic as I could possibly make it. Oh my gosh, Mr. Stevens, that's so basic, right? Alright, so here we go. Let's take a look at a couple of examples. So the first example we're going to do is x to the fifth plus 3x squared minus 4 plus, we're going to do 4x squared plus 7 minus 2x to the fifth. Okay. Now, are we dealing with addition or subtraction? That's a really good question. So what I'm going to do, what I want to look for is, well, what's happening between these two gigantic polynomials? Well, what's that operation right there? Well, that operation says addition, right? We're adding these together. So, following the simple directions here, I'm going to drop the parentheses. So I'm going to drop the parentheses and rewrite this exactly the way I see it. And then on my next step, I'm going to combine like terms. So rewriting this exactly the way I see it, I get x to the fifth plus 3x squared minus 4 plus 4x squared minus 7 minus 2x to the fifth. And now I can combine like terms. If you're struggling with like terms, note, like terms have the same variable and, I'm going to write this big, and exponent combination. Alright, so like terms have the same variable and exponent combination. So I want to write this in standard form. So I'm going to look through the whole thing and ask myself, what's the largest exponent I see? Well, the biggest exponent I see here is a 5, right? So here I have 1x to the fifth and negative 2x to the fifth. And when I add those up, 1 minus 2 gives me negative 1, so I get negative x to the fifth. And I have a tendency to, I like to scratch them off when I'm done. And so next I'm going to look for the next largest exponent. I have a 2, 0, 2, none. So 2. Well, I have a 3x squared plus 4x squared gives me a grand total of 7x squareds. So I'm done with this guy, and I'm done with this guy. So now I have a negative 4 and a negative 7. Well, negative 4 and negative 7, well, if I think about my number line, I go 4 to the left, and then I go 7 more to the left, would put me at negative 11. And that is as far as I could take it. Alright. Addition is really not very difficult. It's one of those things that if you just follow these steps, again, rewriting it is very, very important. One thing that you might have a hiccup is what happens if this is negative right here? Do I say plus a negative 4x squared? No, just simply write minus 4x squared. So that way you could see that this is a negative term. Okay? Alright, let's try another example. One more example here. What happens if I have 2x minus 6 minus Here we have 4x to the third plus 2x minus 6. This is a third degree trinomial, right? Minus 3x plus 2x to the third minus 8. And another third degree trinomial. All right, so what are we dealing with here? Is this addition or is this subtraction? Well, my clue, my indicator is what's happening between my two polynomials. Well, here it is. This is subtraction. And if we take a look at our steps here, with subtraction, I have to distribute the -1 first, and then I can combine like terms. So let's take a look at what happens here. Where is this -1 and where do I distribute? Well, here, this is a positive term. So I don't need to distribute anything to this first polynomial. So for the first polynomial, I'm simply just going to drop the parentheses, and I end up with 4x to the third plus 2x minus 6. Now, there is a -1 hidden right in front of this second set of parentheses, so I need to distribute the -1 to all three of these terms. So -1 times a positive 3x is a -3x. -1 times a positive 2x to the third is a -2x to the third. And -1 times a -8 is a positive 8. Now, some of you are going to catch on pretty quick. Well, all I did was change the signs on these other ones. That is true. I need you to fight your instincts on just ignoring distributing here and trying to combine like terms when they're at the beginning. Please take the time to distribute this negative through, change all these signs, and then combine like terms. This middle step is extraordinarily important and will save you a bunch of errors. All right, now let's combine our like terms. We're looking for the largest exponent like we did on that last one. So here I have a 3, a 1, a none, a 1, a 3, and a none. So my largest exponent is a 3. Here I have 4x to the third minus 2x to the third gives me a total of 2x to the third. And again, when I'm done, I like to scratch them off. Now I have a 2x minus 3x, which is a negative x. That's a minus 1x. Notice that I'm not putting the 1 there. Right? That's a little elementary, and I think we're a little bit beyond that now that we're sophomores. And then finally I have a -6 and a positive 8. Well, if I think about my number line, again, go to the left 6 units and then go to the right 8 units on a number line starting at 0, go to the left 6 and to the right 8, you'll end up at 2. And that is how we add and subtract polynomials.